In this question, we have a particle of mass m projected towards a point O with initial speed √5/3 from a point P, and OP is 3 meters. So we have O to P, or the other way around, whatever you choose, 3 meters. The particle is repelled from O, so there's a repellent force going this way. The particle is repelled from O by a force of magnitude 4m/x³. So we have forces at play here, setting up our acceleration, and x is the distance from O. Okay, so let's say it's here, this could be the distance x, something along these lines. So my force is 4m/x³ is equal to mass times acceleration. The mass is m times a, and dividing by m, we're going to acceleration to be 4/x³. What are we asked to show? V dv dx. Well, x is distance here, so dx will be equal to my s part. And we know that v dv ds is equal to acceleration, so v dv ds is equal to a. Therefore, v dv ds, or dv dx, is equal to 4/x³. So we want v dv, so I just multiply across by dx, so v dv is equal to, they wanted us 4x to the minus 3, so just bring the x cubed up, and we get 4x to the minus 3 dx for part 1. Part 2, how close will it get? Well, if it's not going to get there, velocity will become 0 at some point. So let's say it's starting at P. Let's just do OP again. Starts here and it's trying to get to here. So let's say it gets this far away, and this is my x distance from O. So it starts 3 meters away and it ends up x meters away. So this is my range for distance. So if we integrate velocity, v dv, the initial speed was 5√3, was it? No, √5/3. √5/3. We could probably say it's going in a negative direction and slowing down negative, but I think we're going to end up squaring. It's going to be v²/2 here, so I don't think it makes a difference, but maybe put it in as a negative to be technically correct. This is going to be equal to the integration of the right hand side, and we're starting at 3 meters away and we're ending up x meters away, 4x to the minus 3. So if we integrate both sides, we're going to get v², v to the power 2/2 on the left hand side, between v and √5/3, equal to 4x to the minus 2 over minus 2 on the right hand side, between x and 3. So the left hand side is going to give me v²/2 minus, we're going to get √5/3 squared over 2. So it's going to be 5/9/2. So 5/9 times 2, 18. So we're going to get v²/2 minus 5/18 is equal to, well, tidying up this, we're going to get 4 divided by minus 2 is minus 2/x². If we bring the x squared down, and putting in x, so we're just going to get minus 2/x². Putting x in here, obviously, and then putting 3 in, we're going to get minus 2/9, so we're going to get plus 2/9. And what are we asked to find here? How close we'll get. So, well, let's tidy this up to find v first of all. Sorry, that's a 19. I wrote 19 there. It should be 18. 19 or 18, 9 obviously. Okay, multiplying by 18, I'm thinking a step ahead. Make a mistake, so we're going to just get rid of the denominator, so I'm going to get 18 over 2, 9v squared minus 5 equals minus 36 over x squared plus 4. So simplifying for v, we're going to get 9v squared is equal to minus 36 over x squared plus 9. That'll look like we can divide by 9 now. V squared is equal to, will be minus 4 over x squared, dividing everything by 9 plus 1. So the velocity is equal to the square root of that, minus 4 over x squared plus 1. And we are asked for how close it gets and the speed when it's traveled half this distance from P to this nearest point. Okay, well let's put V is equal to 0 in first. So when is this whole thing equal to 0? So for this to be equal to 0, the square root is 0, 0, this would have to be equal to minus 1. So minus 4 over x squared is equal to minus 1, so x squared would have to be equal to 4. So x would have to be equal to 2. So it leaves here to try and get to here, a distance of 3 meters, and it travels 2 meters. Travels this distance 2 meters. And we're asked to find the speed when it's traveled half the distance from P to this nearest point. So when it's traveled half that distance. So how far has it traveled when it's traveled half that distance? It's just traveled 1. And I am of course looking at the distance the wrong way around. It gets 2 meters. X is 2, X was this distance. It gets 2 meters from there. So this is 1 meter. Half that distance is 0.5. So the velocity at this point x is going to be 2.5. So just sub 2.5 back into the equation here. The velocity when x is equal to 2.5 minus 4 over 2.5 squared plus 1. Just type it into a calculator. It's giving me 0.6 meters per second for the last part of this question.